All right, my name is David Steele. I'm from Arcturus. We're a software company that works with Synaptics. So we do edge AI and vision systems. And what we're demonstrating here is kind of an industrial use case using the Synaptics SL1680, which is sort of the flagship Synaptics processor. It's a quad-core A73 with an 8 TOPS NPU. What makes it really good for industrial applications, what they're trying to do is deliver something that fits underneath where NVIDIA is sitting at, which can't be used in industrial, and above where we're seeing these sort of crossover microcontrollers and low-end processors, right? And so from the focus of adding ML and AI capability, and pretty good ML and AI capability, and pretty good encoding capability as well, at a price point that's really quite aggressive in the market. And so we think that that combination is kind of a recipe for success. So we're hitching our wagon pretty heavily on this. Yeah. Temperature range is -40 to +125 junction, fanless, convective cooled, really great for industrial environments. Where we're demonstrating is a fairly straightforward industrial inspection application. We're looking to detect good parts versus bad parts. And that's usually enough to get the industrial guys kind of excited because they can see how edge AI can be applicable to their domain. But the first question they always ask us after we show them this is, they say, well, that's great, but this is one camera with one device at the edge. My production facility, one line has 30 cameras and I've got 15 lines. So how do I get it from there to a real production environment? And so to address that, we provide some tooling. So this is called AccuSight. It supports 3 core things. Number one is it aggregates all of the data from the devices and presents it into a real-time dashboard. So this is the real-time dashboard. It shows you production metrics. You can get drill-down workflows. This is this device right here. So I can see everything that's going on into it, including right down to the CPU temperature. The second thing that it does, that AccuSight does, is that it controls all of the device configuration and management. So we can configure the devices, onboard them really quickly and simply, set them all up. And this is a Dockerized environment. And what that means is we have a really powerful management capability based on Docker as well. So we can look at specific containers and how they're performing. I can get access to logs. I can get a console right into devices. So very powerful management and configuration capability. And then the third thing is it provides, was just sort of demonstrating, was this is an industrial sort of vision application where we're doing inspection. So we're looking at good parts versus bad parts. And what happens with the industrial inspection and industrial customers is they get differences in their production, so variability in production. And so an example of this is I may be manufacturing white cable glands for 364 days of the year. Then my number one customer says I need blue cable glands. And then when I put those into my inspection line, I've got a problem. So what we've done is, and one of the value propositions of edge AI is that we can learn from the real world data, adapt our model and redeploy it. Normally, that's been the domain of data scientists. That's what they do day in, day out. They build data sets, they train models. What we've done is we've built those workflows into our tooling. So it takes it from the data scientist and puts it in the hands of the operator. So how we do that is we get data from the edge, and then this data is collected into batches. Batches then get moved into a project. I've got a project already set up here. It's called glands. And then I can look at the batch data that's coming in, and then I can annotate it so I can teach my model what a blue gland is. So then once I've built that data set, I can then build my model. And so we have all of the model building workflows in here. So I'm not going to build a model because it'll be watching a progress bar for about 30 minutes, but I built one already. And I think this really helps to highlight one of the value propositions that Synaptics provides. So I'm just going to deploy this model to this device. And if I'm really fast, I can get back to my live video interface, and it's already updated the model in real time. So one of the cool things about the Synaptics SoC, and one of the things that we haven't come across, and we supported a lot of SoCs that have NPUs, is that we can actually swap that model in real time with no NPU warmup, no reboot required. So it's a really cool additional feature that Synaptics offers. Another cool feature that they offer is actually we can put the pre-processing functions inside the model as well. If you know anything about Edge AI, you'll understand that pre-processing functions are normally done on the CPU, but with Synaptics, we can actually move those pre-processing functions into the model. Normally, that pre-processing can take as long as the forward pass of the model on the NPU when it's running on CPU. So that gives us some pretty cool flexibility as well. So one of the things we have not seen on any other NPU. So, and I can just sort of change the model. So I just can go to a different project and just deploy that model. And there we go. So what we're looking at here is we've trained a model to do a couple of things. It's looking for a properly formed label so that it isn't damaged or distorted. And it's also looking for this warning sticker. The model doesn't care where the warning sticker is, just as long as it's there. So it's kind of one of the benefits that AI can bring is that level of variability, because you know, you have a human that's applying these in a pharmacy. You know, you want to make sure as the unit gets shipped out, it has the label. You don't care really where it is, but with traditional inspection, it would have to be precisely in that geometry because it needs to be an exact match. So that's what we're kind of doing with this. How often, like how easy it is for the customers to train the model, pre-train or retrain the model. Well, I was just showing you the workflow. It's really that straightforward. That's it. That's it. Yeah. Wow. Yeah. So we have the full training in there. And I can show you well, let me just go to a model here. So we use that TF Lite. So as our base model, that's what we standardize on internally. And then we can export the model to whatever specialized compute formats required. So in the case of Synaptics, that's using the Synapse model format. So we just take that TF Lite model and then we push it through to create a Synapse model, which is going to run on the NPU. It's going to be optimized for that NPU.
In the case of labeling that's FDA required certain things, is that something you preload or do you let the client create that? Things that are government mandate in terms of where labels need to be.
Yeah, so we can do it either way. We generally have an engagement as a client, so we generally provide a standard, what we would call a production model, okay? But what we're kind of illustrating here tends to be what we've referred to in AI as drift, right? Drift is when there is a variation in the data the model is seeing in the real world from the data the model was trained on. So that's really kind of the intent of this tooling. But that said, what it does give us the opportunity to do is actually put a model into production faster because we can still learn from the real world variability. Normally in a data science process, you have to go through all of your validations before you deploy that model. Now you can deploy the model into the real world and then do that validation in parallel, right? So I know that's a roundabout way of answering your question, but my point being that we can actually accelerate that process,